Okay, see Lindelof videos, area of the sector of a circle. This is going to be a short video because I think this is pretty straightforward. I was going to do a problem that had the angular measure in degrees, but I thought maybe it would be good today to do one that's in radians. So I just want to find the area that's in bold here, and you can see this. So I'm trying to find this area right here. I'm trying to find this area. I'm trying to find the area enclosed in here, right? Trying to find this area. And we know that the area of a circle, so the area of a circle is equal to pi r squared, right? Pi r squared. However, the area of a sector is pi r squared, right? Times the percent of the circle that we get, because we don't get this piece right here. We don't get this piece here that's in blue, right? This is not ours, right? So we don't get this part. We only get what's in orange here. So what we're going to do is this. We're going to set it up that way. We're going to say pi r squared. So we have pi. Whoops, let me do this better. We have pi r squared. R, I'm not sure you can see this anymore, is 4. So here's that 4 right there. Is 4 squared times, and now we have to figure out what percentage of this circle do we get. Well, it says here that we get 3 pi halves of it, so here's this 3 pi halves. However, when you do radian, right, if you do radian measure, the all the way around a circle, right, your 360 degrees in radians is equal to 2 pi. So it's equal to 2 pi here. So this does, especially if you're in pre-cal or in honors geometry, your teacher or your professor may ask you to leave this in symbolic language. That is to say, not to round. So I'm going to go ahead and do this piece of math. So I'm going to do it down here if you don't mind. So 4 squared is 16, and it's 16 times pi, right? So 16 times pi. And now we have this. This is what's called the theorem of complex fractions. So what we have to do here, right, is look at this. We have a fraction over a fraction. So remember that what we do here is we take the top fraction, and then we multiply by the reciprocal of the bottom fraction. So we're going to multiply by 1 over 2 pi. Okay, so let's actually do this math a little bit. You can see that these two cancel, right? That is to say, they go to 1. We would have 3 pi over 4 pi. So we'd have pi over pi, which would be 1. I hope I'm not over explaining this to you guys. But 3/4, right? So I'm just going to do this symbolically. So symbolically, this would give us 3 times 16 is 48 over 4. Right? That's me multiplying the 16 into 3/4, and then pi would remain here, right? Right? So cleaning this up a little bit, so 48 divided by 4 is 12. So our answer symbolically is 12 pi. And the reason that this symbolic answer is better is because there's no estimation error made here. There's no rounding error in this. This is an exact value. However, if you did do this and you had to round, then it would look this way. I just grabbed this off of a calculator. So we have the same problem here. We have the pi times 4 squared. We have 3 pi halves divided by 2 pi. And when I put all that into this calculator, I got 37.69. And if you multiply 12 times pi, you get this exact answer. So depending on how your professor or teacher asks for this, these are the two ways I would present these answers. That was pretty quick. I hope this was relatively easy. I think I might do one more problem using degrees. If I use degrees, then of course I would have degrees. Let's say it was 270 degrees. I'd have 270 degrees over 360, and that would give me the percentage of the circle that I got if we were using degree measures of angles, but we didn't. We use radian measures. So again, hope this worked out for everybody. If you have questions or comments, you know I do my best to respond as quickly as possible. And if you haven't already subscribed, please do. And I'll talk to you later.